Hello, everybody. Today we are going to talk about slope and how to find slope and what it means. So you want to find this page in your packet so that you're looking at the right page to be able to do the notes on. And you're going to write down what we're writing down so that you have this as reference. We've been talking about graphing linear equations, so we are going to look at what the slope of a linear equation means. And the slope is essentially how steep a line is. How steep a line is. So we use steepness when we're talking about maybe a sledding hill or a skiing hill. And if something going downhill goes down fast, it's going to be really steep. If you've got a hill like this, you're not really skiing down that quite as fast or sledding down that quite as fast, so that would not be as steep. Same thing with like uphill. If you've got a driveway, does anybody have just a flat driveway? A flat driveway would be zero slope. It's not very steep, but maybe your driveway gets a little bit steeper, or I think some of you guys have a pretty big incline driveway, a really steep driveway that's hard to get up there in the Michigan ice. That would be super steep. So how steep a line is slope, and it's actually a number. We use a number to show how steep something is. So here's how we would actually find the number, give it a value for how steep it is. I'm going to use another example. I'm going to talk about staircases for a minute. Will you guys draw a quick coordinate plane right here? And will you go ahead and draw a line that looks like it's going uphill like this? When we say uphill from left to right, you're going to start going up. Okay, if you had this as your staircase, would that be really steep? And here's how we would find out if we put some kind of equally spaced points on this line. We know those aren't the only solutions on the line because there's an infinite number of solutions. But if I went then between these points, I wanted to see how steep that staircase was. Let's actually make a staircase above there. Up and over, up and over, up and over. That would look like a staircase now. Right? To see how steep that is, we would have to see how far do we have to lift our leg, and then how far do we have to go over to get essentially to the next stair. Up and over, up and over, up and over. Okay? How many people have ever been to a really, really steep staircase before, where you had to lift your leg really far and then just maybe go over a little bit? Something maybe more like this, where you're going up and then over just a little bit, up pretty far, then over just a little bit, up pretty far, then over just a little bit. That would be pretty steep. The opposite end of that might be a movie theater staircase. You know, those movie staircases where you just go up a little bit and over a lot. They're like really wide, flat stairs. Up a little bit, over a lot. That would be not very steep right there. So all of these would have different slopes, different steepnesses, and to count it, to give it a number, we would say how far do we go up and how far do we go over. And that number I'm going to point right here. How far do we go up between those up points? That's called our rise. How far do we rise our foot up? And then how far we go over, this one is called our run. So how far do we go up and then how far do we go over? And we actually take those two numbers and we divide them. The rise divided by the run. And that is going to give us an actual number for the slope. So rise divided by run. So if I went up 1 and over 1, my slope would be 1 divided by 1, or just 1. If I went up 2 and over 1, my rise would be 2 over 1, or 2. It would be a steeper slope. Maybe here I'd go up 1 and over 4. It would be 1 over 4. My slope would be 1/4. It would not be as high of a number, so it would not be as steep of a slope. So in figuring out how steep something is, we actually count and we calculate rise over run. So I'm going to show you a few different ways that we write this. I'm going to have you put these down too. The rise, when we go up and down, which part of the ordered pair controls up and down? Which coordinate? Up and down is the y. So from here to here, the change right there is just the difference between the two y values of these 2 points. So we say the rise is also the change in the y's. Rise, y's. Change in y's. and that just means the change in the up and down. The run, side to side, which one controls side to side? That's the x. So it's the change in the x's. So we count what's the change in the y's here and the change in the x's side to side, and we divide those. That gets us our rise over our run. There's a shorter way to write this. Just going to show you some math notation real quick. There is a symbol that we use that looks like this. It looks like a triangle, but it's actually a Greek letter. It's called delta when you say that out loud. So delta means the change in something, the difference in something. So we just say delta y, the change in y, delta y, divided by the change in x. So you might see that as just a shortcut way to write this, the change in y over the change in x. All right, there's also one more way that we are going to look at that we're going to write down and talk more about later. But if we're actually finding the change in the y's, we might want to look at the actual coordinates, the actual y's. So let's pretend here that this was 1, 2, 3, 4. Okay, how far did we go up between these two? We went up 1. What is the change in their y's? Well, this y value was up 1, this y was up 2. So the change in the y's would be 2 minus 1. Our change is 1. So to get that rise, we also can subtract the y values of these two ordered pairs right here. And the way we do that is we would do y minus y, the two y values, this y minus this y. And then on the bottom, to get the x difference here, we would do this x minus this x. What's the difference between those two x's? X minus x. And there's one little last notation that we use just so that we know which y's and which x's we're talking about. We put a little 2 and 1 underneath these. This is y2 minus y1. That is not a squared. That doesn't mean y squared. This is called a subscript. It goes underneath it. It just means the second y and the first y. You just have two ordered pairs you're comparing. The first one and the second one, and you subtract them. This is x2 minus x1, the first x and the second x, and you subtract them. So we're going to play around a lot with this more and understand how to do that and what those mean, but at least we have it written down to reference back later. Okay, before we go on and start calculating slopes, I'm going to tell you guys what slopes should be positive, negative, and we're going to look at some horizontal and vertical lines as well. So down here, we are going to go down and we are going to make, actually quickly, can you make 4 sets of axes for me? 4 coordinate planes. Don't have to be super big. And we're going to look at the 4 different types of lines that we can have and talk about what their slopes would mean. So, 4 different types of lines. Left to right, a line could go uphill, similar to what we just did. That would be an uphill line. Okay? The slope of an uphill line, the slope is positive. It has a positive slope. The number associated with it is going to be positive, like a positive 2 or a positive 1/2. It's going to be positive. If going from left to right, your line goes down, okay, then that's going to be a negative slope. So left to right, going downhill has a negative number. It might be a -3, it might be a -1/4, but it's going to be a negative number. If we had, do you remember when we did some horizontal and vertical lines? If you had a flat line, horizontal, like a flat driveway, there is a slope of 0. The slope is called 0 because there's really no change. There's no steepness to it. It's got 0 steepness. It's got a 0 slope. And then the only really interesting one is when we did that vertical line. You remember this one? Okay, vertical lines are so interesting to us because we don't work with them very much. I can't actually even type in a vertical line into the graphing calculator to graph it for me. Do you remember what kind of equation gave us a vertical line? It didn't matter what y was, x was always equal to something. So let's pretend this is like, I don't know, here, x always would equal 2. That would be the equation of the line. Can I type that into a graphing calculator? No, because the graphing calculator has to start with y equals. So this can't go in there, and for those of you that have been introduced to the 8th grade concepts, it's because this is not a function. The graphing calculator can't graph it because it has more than one x value, more than one y value for the value of x equals 2. Can't be graphed. And for that reason also, it doesn't really have a slope that we can talk about. You can't really walk up a straight vertical line. You can't really walk down, right, like you could here. This would be positive, this would be negative, but you could still walk them or ski them or climb them. This one you'd have to be like mountain climber and climbing straight up. So we say that this one has an undefined slope, and mathematically that's a mathematical word for when the bottom number of a fraction is 0. And we're going to talk about this, that the rise over the run, the rise could be anything, but the run, it doesn't go side to side. It's 0. So you're going to have something divided by 0 for your rise over your run, and you can't divide something by 0. That's undefined. So we say that it has an undefined slope. We can't calculate a slope for that one. So there is a really hilarious story that will help you guys remember positive, negative, 0, and undefined slope. It's called Slope Dude, and I'm going to have you watch that video also today so that you can help remember why these things, or it's a way to help you remember which ones are which ones on here. So Slope Dude, keep that in the back of your mind. All right, let's look at how to actually calculate these positive and negative and 0 and undefined slopes. We're going to skip this part for right now, and we're going to go to the next page. The one that starts with example 1, find the slope. Okay, so looking at this one right here, it asks us to just find the slope of the line shown. And to find the slope of a line, we want to be able to calculate or count. I'm just going to write this here real quick. Rise over run. Change in y over change in x. And they, on this graph, they already graphed the line. And do you see how they gave us a couple of points already on the line? They picked out points that hit these grid lines exactly at whole numbers. And we could pick any point on the line to use, but if it's something like in between here, it's hard to tell from the graph what it's supposed to stand for. We want to use on the graph lines that hit these grid lines perfectly so we know they're whole numbers that we're working with, at least integers on there, right? So they tell us let this x1, y1 equal -1, 2. So side to side, -1 up to 2. That's our first point. And instead of saying just x and y, x comma y, they say x1, y1 because it's just the first one. The first x and y are this. The second x and y are 3, 5. Does it matter which one we call the first and which one we call the second? No, it doesn't. It's just they're two different points we're using, point 1 and point 2. So if we want to find the rise over the run, we're going to count it. We're going to pretend that this is a staircase. To get from here to here, I'd have to go up this far, and I'd have to go over this far. And we're literally going to count it. How far would I have to go up? I'm rising how many? 1, 2, 3. I'm rising 3. And I'm running. For running, I always run to the right. I'm running to the right. 1, 2, 3, 4. So my rise is 3, my run is 4. 3 divided by 4, or 3 over 4. And for slope, guys, we want to leave it as a fraction because it makes more sense to us to visualize up 3, right 4, up 3, right 4. What that means is if I did this again, I went up 3 more, and I'm going to go off the graph a little bit, and right 4 more, 1, 2, 3, 4, it means I would hit the graph again. Does it look like that line is going to go that way? Yeah. It also means that I could continue this pattern this way. Instead of up and right, could I go down and left? Would I hit it again? Down 3, left 1, 2, 3, 4. Yeah, look, I'm going to hit it right there too. So that pattern continues because my slope is always the same no matter which points I pick on that line. So I want to leave it as 3/4. It wouldn't make sense for me, well, we could, but it wouldn't make as much sense for me to turn this into a decimal. We're not going to do that because that would be 0.75. And then I'd have to look at making that back into a fraction to be able to count up and over. So when we're looking at slopes, we usually leave them as fractions. That's our final answer right there, 3/4. Okay. Let's look at this guy. The first point is 1, 4, x1, y1. The second point is 3, -2, right here. They picked those 2 points for us. What if they hadn't picked the points? We would have to find them ourselves where it hit the grid lines exactly. And guys, can you see this one? Doesn't it look like this one hits the grid lines exactly? So there's another point that we could use as well for ours. So for this one, I'm going to figure out my rise over my run again. It's always rise over run. But I'm going to go back here for a second. This one, the line went uphill, right? Look at my slope. Uphills have a positive slope. 3/4 is a positive number. This one is going to be going downhill. So this slope is not going to be positive. This is going to have a negative slope. We want to keep that in the back of our minds here, and let's see if we can get that mathematically as well. So to go from this to this point, we always want to go from left to right. If I went up and right, would I be able to hit the line again, up and right? No, I'm going to have to go this time down and right. And I'm going to have to put like the stairs underneath the line. And then from here to here, I could go down and right. Can I count my rise over run on this stair right here? I'm going down how many? 1, 2, 3. I'm going down 3. So think about down is going to be negative. That's where my negative comes from. Going down 3. I'm not really rising 3. I'm rising a negative 3. I'm going down. And then over my run, how many would I go side to side? Running to the right, 1. Negative 3 over 1. So I could leave that as a fraction. A negative divided by a positive would make the whole thing a negative. I could make it negative 3 over 1. I could turn it into negative 3. That's okay. And then if we wanted to picture it as a fraction, what would I do? I would just end up putting a 1 over it. So I could leave it as negative 3 over 1 or negative 3, and those both would indicate my same slope. Does that work here? Can I go down 3, right 1 to get to my next point? Absolutely. Let me show you what would have happened if I didn't see this point in the middle here, right? If I just used the first two they gave me like they indicated here, I would go all the way down here and all the way over here. How many would I have gone down to get from here to here? 1, 2, 3, 4, 5, 6. I would have gone down 6. And how many over? 1, 2. Over 2. Right 2. What's negative 6 divided by 2? It just takes me to negative 3, right? So no matter which point you use on the line, you're always going to end up with the same slope. So our strategy here was just literally counting. Rise over run, and if we went down and right, we had to remember that it was going to be a negative slope for a downhill line. So let's get really good at just doing that from a picture and counting the slope from a picture. We are going to skip ahead to a couple of pages, quite a few pages. We are looking in the packet for the one that says, what did the inventor of the 10-ton truck so often say? All right, and we are going to, for each exercise, draw a line through the two given points, find the slope of this line, and write the letter of the exercise in the box containing the slope. Let's see what this means. All right, it says 4, 4, and 1, 2. Let's put those dots on here like we did with Fishy. 1, 2, 3, 4, up 1, 2, 3, 4. There is 4, 4. And let's do 1, 2. Over 1, up 2. That is going to be our line right here. It says draw a line through the two given points. So I am going to get a piece of paper, something, a straight edge to be able to draw my line through those. Okay, there's my line. And it says find the slope of this line. So can I find the slope? I want to go rise over run. Between my 2 points that I just drew, I would have to go and make my staircase like this. How far am I rising? I rise 2. I'm going to put my work here. Rise 2. And I'm running to the right. 1, 2, 3. Rise 2, run to the right 3. I get 2 divided by 3, 2/3. And does it make sense that it's positive? Is my line going uphill? Yes, indeed. And just to make sure, I want to put like a B next to this line in case I find out later I made a mistake and I have to figure out which one goes with which. I'm going to put a B showing that this was B. So what I'm going to do then at the bottom is I want to find where it says 2/3 and I want to put a B. Which one down here has 2/3? Looks like the middle. I'm going to put a B right here. Hey, look, there's also a negative 2/3. So we want to make sure that when we get an answer that we really should have the positive rather than the negative version. This one's going uphill, so it's definitely positive. And then we're actually going to draw 2 more lines all on this same set of this same coordinate plane. So now I'm going to do 2, 0. If you have different colors, you could use different colors. I'm going to use a pen for this one, or you could use all the same. It's fine. I'm going to go over 2, 0, over 2, up or down 0, and then negative 4, 4. From my origin here, left 4, up 4. 1, 2, 3, 4. Ooh. So this is going to be a line that's going like this. I'm going to write this was E, just so that I don't forget which one it is. And I need to find the slope of E, so I want to figure out, rise over run, how to get from left to right, from here to here. Now, if I go up and over, I'm never going to hit it. I'm going to have to go down and then right. So how many am I going to go? Down would be 1, 2, 3, 4. So I'm going to go down 4, and down automatically should make me think negative. Negative 4. And running to the right, 1, 2, 3, 4, 5, 6. The right, 6. So I get negative 4/6. All right, so we know it's going to be negative. Can I simplify 4/6? Yeah, 4/6 is just 2/3. So this becomes a negative 2/3. That's my simplified version of it. So that was E. E gave me a negative 2/3. So I'm going to go to the bottom and find negative 2/3 and find E. All right, and we knew this was going to be negative because it's downhill. So from now on, I'm always going to ask myself, once I draw the line, negative, positive, 0, what does it look like it's going to be? So one more graph on here, 1, negative 3. Okay, we got lots going on. Here is my origin. So over 1, down 3. And then the next one is negative 3, negative 4. 1, 2, 3, 1, 2, 3, 4. So left and then down, negative and negative. So it's going to look like this guy. And this was my O. Let's find the slope of O. Does this look like positive, negative, 0 slope? What would this be? This is positive. It's going uphill. So I'm going to go up, rise 1, and run how many? 1, 2, 3, 4. Up 1, right 4. Rise, over, run. Up 1, right 4. So my slope of this line is 1/4. It's not as steep as my 2/3. 2/3 is a bigger fraction than 1/4. So the 2/3 line was steeper than the 1/4 line. Right? So do we have a 1/4 at the bottom? Let's hope so. And we're going to put an O there. Yep, down here. Okay. So you guys are going to finish this worksheet to find out, what did the inventor of the 10-ton truck so often say? This is not a great one. We'll see if you guys like it. And then, so I'm going to have you pause the video and then come back and check your work with it. Okay, if you're still watching this part, I'm assuming that you have this worksheet done. I'll show you the answer just so that you know the riddle, and you'll be able to show me the worksheet next time. All right, here is our riddle at the bottom. You shouldn't have anything in the first, the last, or these couple middle ones. It says, diesel be good. So the idea is that a 10-ton truck runs on diesel fuel. So he invented this 10-ton truck. So it's like, these'll be good, but diesel be good because it runs on diesel fuel. Yeah, told ya. So there were some of these on here that when you ran into it, like S, there was one over here where you should have gotten it had a 0 slope. This guy right here, because it was completely flat. So we ran into a 0 slope. There were none of them on this worksheet that were graphed as straight up and down as verticals, where we ran into that crazy undefined thing yet. So what we are going to do at this point to finish up is we are going to look at what happens if you can't graph the points or you don't want to take the time to graph them. Graphing is one method to find the slope. You just count it. But I could actually do it with all these points with a quick calculation where I didn't actually have to graph and count. I could just use what I know of these points right here. And so that's the last thing I'm going to show you today. We are going to go back to, let's find where we're going. Actually, this page, a couple of pages back where we just counted the rise over run for these two. So can you find the one that said example 1? And we're going to look at B. When we did this, we counted. We went down 3, right 1, down 3, right 1, and we got that the slope was -3. We're actually going to pretend that we don't see that graph at all, and we're just going to use this information right here. And we're going to say, well, to have found out how far we went down, the down we said was the y values, the change in y's. And the side to side would be the x values, the change in x's. So if I do some calculations with the y's and with the x's, I should be able to get my rise over my run without actually counting it. And here's how we do this. We can just use this area over here as some workspace. The original page that we did, I gave you this formula. Oops, I'm going to start with this. I'm going to say slope equals y2 minus y1 over x2 minus x1. Okay? And we're going to get used to seeing that. That is just the way that we can calculate slope based on the x's and y's that we're given. Okay, so if we're looking at these right here, our x1, y1 is right here, 1, 4. Our x2, y2 is 3, -2. So which one is our y minus y? Our y2 minus our y1. The y's are always the second ones. So that would be -2 minus 4. I'm going to write that out. -2 minus 4 on the top. That would be the y minus the y, the second y minus the first y. Then we're going to do our x's on the bottom to find our run. Our second x minus our first x, 3 minus 1. And now that is the math problem we need to do. What is -2 minus 4? Getting smaller, you can change it to plus a negative if you want to, if it helps you think about that. -2 minus 4 or plus a -4 goes down to -6. On the bottom of this fraction, what's 3 minus 1? 2. What's -6 divided by 2? -3. And what was our slope of this line when we counted it ourselves? -3. So if you can get used to doing y minus y and x minus x, you don't have to even take the time to draw a coordinate plane and graph them and count. You can just subtract y minus y and x minus x and get the actual slope for that. We're going to try this a couple more times for sure until we get the hang of this right here. y2 minus y1 over x2 minus x1. Can you go to the bottom of this page where there's a little thing that says checkpoint right here? We're going to try this the same way. We're going to call this xy. Ordered pairs are always xy and another xy. But which one do you want to be the first point and which one do you want to be the second point? It doesn't matter. Should we do this one as first because it's the first in order? This would be then our x1 and our y1. And this second point would be our x2 and our y2. So can you guys write, let's do our at y2 minus y1, the change in y's, over x2 minus x1, the change in x's. Can you make me the math problem for this? Let's find our y2 minus y1. That would be 1 minus -1. We got to write this carefully. 1 minus -1 on the top. And then we go to our x's. I'm going to put boxes around our x's here. x2 minus x1 would be -2 minus -3. -2 minus -3. Okay, this has a lot of subtraction and minus and negatives, and I'm going to change my subtraction to adding the opposite. Minus a negative becomes plus a positive. Minus a negative becomes plus a positive. Now it's going to be way easier to think about. 1 plus 1 is 2. -2 plus 3 is 1. What's our slope? 2 over 1 or 2. You could simplify it to just 2 or 2 over 1. Either way, that would be our slope for this. And we didn't have to take the time to graph it. As soon as we get used to doing the y minus y and the x minus x, this becomes a quick calculation. So let's try it with this guy. It's always x comma y. Sometimes people want to do x comma x because they're used to putting x's together and y's together. But ordered pairs are always xy. xy. And since this is the first ordered pair, should we call this x1, y1? And this is the second, x2, y2. It honestly would not matter. We could call this one x2, y2 and x1, y1, and we would get the same answer either way. Slope's always going to be the same. So I want y2 minus y1 over x2 minus x1. Change in y over change in x. And let's fill in our numbers for this. What are we going to get when we do this one? All right, we've got my y minus y. That's the second one's in order. Negative 2 minus 3. And my x minus x, 5 minus negative 6. x2 minus x1. All right, let's try this. I can change subtraction to adding the opposite if it helps me. Negative 2 minus 3 is like plus a negative. Negative 5 on the top. And minus a negative is like plus a positive. 11 on the bottom. So I get negative 5 divided by 11. Negative 5/11. That's my lovely slope right there. That's all it is. It's a negative, so what does it tell me about the line? That it's going downhill. Yep. All right, so looking at these, the most common mistakes that we see, most common mistake is accidentally putting your x's on the top. Because we're so used to the x's coming first, we tend to want to do them first. And you've got to make yourself do the second one first, the y minus y going on the top. We're going to do 2 more examples just so you can see what happens with horizontal and vertical, and then you guys are going to be ready to practice this on your own. So next page where it says checkpoint, at the bottom we're just going to skip the top stuff because we've done that practice before. Can you find the slope of these lines? The same way we just did. Try labeling this x comma y, x comma y, but this we'll call it x1, y1, x2, y2. It's the second one. So I'm always going to write this every time just to remind me, y2 minus y1 over x2 minus x1. And let's do our math. y2 minus y1, the y is the second one's. 3 minus negative 2, be so careful with those negatives. And on the bottom, 1 minus 1. Okay, let's see what we get. Minus a negative becomes plus a positive. And you get 5 over, what's 1 minus 1? 0. What's 5 divided by 0? It's not 0. We can't do 5 divided by 0. If you do it in the calculator, it'll give you a little E. It'll say error, because you can't take 5 things and divide them into 0 piles. It doesn't work. This, in math, is the answer that makes us say undefined. And it's because if you think about this, over 1 down to negative 2, over 1 up to 3, what kind of a line is that going to be? It's going to be vertical. Over 1 down negative 2, over 1 up 3. It's going to be vertical. Its slope has to be undefined. So you might get a situation like this with a 0 on the bottom. Let's try this guy, see if we get the same thing. Are we going to get a 0 on the bottom? y2 minus y1 over x2 minus x1. As you get faster at this, you might need to label the top. I'm just going to do my y minus my y. 7 minus 7 on the top. And my x minus my x. 4 minus negative 3 on the bottom. So on the top, 7 minus 7, that's giving us 0. What do we get on the bottom? Minus a negative becomes plus a positive. So we get 4 plus 3. So 0 divided by 7, is that undefined? No, 0 divided by 7 is just equal to 0. And you would need to simplify that all the way down to 0, because 0 divided by 7 wouldn't really stay that way. We would move it down to 0. That's the simplest form for that kind of slope. And a 0 slope happens when you've got a horizontal line. Over negative 3, up 7, over 4, up 7. This is going to be horizontal at y equals 7 no matter what. And that's why it gives you a slope of 0, because there's no steepness to it. All right, you guys are going to try a checkpoint that lets you practice all sorts of things about slope. You've been doing a great job, and I will see you next time.